Good evening. Lesson 5. We're going to focus on table G this lesson in our solutions unit. Our targets are a little bit complex here. This is going to be I'm going to talk fast in this video because there's a lot of material to cover. We're basically going to focus on how to use table G, all the different ways that you can use it. Okay, saturated, unsaturated solution, given amounts of solute and solvent, how much material will dissolve. And we have to use table G for this. Okay, so changes in those values also will ensue. So as the temperature changes or the amount of material changes, you have to be able to use table G to track those changes. And so let's get into it, all right? If our solute mass and temperature fall along a curve of interest, we've got a chemical solution that is considered saturated. For example, 40 grams of sodium chloride at 90 degrees Celsius. Let's see if I can see my mouse here. 90 degrees Celsius, down here, 40 grams. 40 grams, 90 degrees, boom, point is right on the line. Let me put a star on that spot on the graph. We're hitting, boom, right on the line on that spot. We have a saturated solution. If you hit on the line, it is saturated. That's what I want you to know. If the mass and temperature are below the curve of interest, we have an unsaturated scenario, meaning you could put more solute into your liquid. For example, potassium nitrate, 70 grams of it at 60 degrees Celsius. 60 Celsius, 70 grams, those cross right in here. That spot is below the potassium nitrate curve and therefore not saturated, unsaturated. Now, if we are in a position where we're above the curve of interest, we have a supersaturated scenario. For example, 110 grams of sodium nitrate at 20 degrees Celsius. 20 Celsius, 110 grams. This point's right there. NaNO3 is right here. That point is above the curve. We have a supersaturated scenario, okay? So as you use this chart, what you're doing is you're basically playing Battleship. Find your X value, find your Y value, and compare it to the chemical of interest. So problems that ensue are things like how much will not dissolve? Well, mass that will dissolve minus the mass that is added is how much does not dissolve. For example, you got to use table G to find the amount that will dissolve. You subtract it from the amount added, and that gives us the amount that will precipitate with a change in temperature. Okay, mass dissolved at a higher temperature minus the mass dissolved at a lower temperature is the masses that's going to fall to the bottom. So if 100 grams dissolve at 50 degrees, but only 40 grams dissolve at 20 degrees, the difference there is 60 grams. If you change the temperature, the amount of material that dissolves will also change. Table G will find the amount that will dissolve at each temperature. You subtract and find the difference. You see how much material falls to the bottom. Solubility when the amount of solvent is greater or less than 100 grams of water. This is where we're going to have to double or half or triple our solute amounts at the end to see if our data of interest falls on this curve, saturated, supersaturated, unsaturated, little math ensues. So if 30 grams should dissolve at a temperature, how much would dissolve if we doubled the amount of water? Well, if 30 grams dissolved in 100 grams of water, you double the amount of water, you should be able to dissolve double the amount of material. So you would double it. If the amount of water doubles, the amount of solute that would dissolve doubles. If the amount of water is halved, the amount of solute that dissolved will be halved. Okay. Which compounds are solid looking at table G? I could tell right away because I know that solubility increases with temperature for solids. Which samples are gases looking at table G? Well, I can tell you very quickly because as you increase the temperature, the solubility of a gas decreases. So 3 curves decrease and the rest of the curves increase, showing solids and gases. But we should probably do some example problems so you really get a better handle on it. So 60 grams of HCl and 100 grams of water at 47 degrees Celsius. Is that saturated, unsaturated, or supersaturated? Well, you look at the chart. You go to HCl, there it is, 60 grams, there that is, and 47 degrees, about there. We look at this spot, boop, 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 boop. Looks like we're right on the line. So that, you write in your notes, would be saturated, okay? The next one we want to do. Potassium nitrate, different chemical, different curve, different temperatures, different masses. So potassium nitrate, 100 grams of water, 20 grams. Let's do it and see. 20 grams KNO3, there's 20. 20 degrees Celsius, so the point of interest is right there. And then we compare it to KNO3. Well, the KNO3 curve is much far above that, so that is an unsaturated solution. You write it down in your notes, unsaturated solution. Okay. Next example, 70 grams of NaNO3 and 100 grams of water at 10 degrees Celsius. You get your 10 Celsius, 70 grams of solute. The point of interest is right about here. NaNO3 is above. We've got our unsaturated scenario. Okay? You write it down. So we're using the chart, we're comparing numbers to the curves, and we're deciding if we can add more or less. Different type of problem. Finding the amount of solute to be added to 100 grams of water to make a saturated solution. So NaNO3 at 40 degrees. Well, we got 40 degrees, and we got this NaNO3 line right there. How many grams should be added to make a saturated solution? Well, saturated is when it hits the curve right on the line. So at that temperature, 40, it looks to me like about 100 grams of material would be allowed to dissolve in there. So our answer would be something like 100 grams. Okay. So to figure out how much could be added, you find the temperature and the chemical, and you trace up to see the line and what would make a saturated solution. KCl3 at 30 degree. Well, same process. You go to 30 degree, you look for KClO3, that's this curve right here, okay, a different one. How much should be added to make saturated? Well, we go up to hit the line. It's not very much, probably about 10 grams, not 100, about 10 grams there, okay? I'm not sure if that's showing up, but you should be listening so you can get your answers. Now, let's see what else we got here. KNO3 at 50 degrees. Well, you go to 50 degrees, find KNO3. I'm going to do a little race in here. KNO3, that's a big long curve, 50 degrees. You trace up till you hit the curve right about there. Looks to me about 80 grams. Okay, about 80 grams. So to find out how much would be used to make a saturated solution, you just find the temperature and curve of interest, trace up until it hits the curve, read to the left, and you've got your mass. Mass of solute that does not dissolve. So this is a scenario where we've added too much solute. So here we go. We're going to find our points that are above curves in this case. If 60 grams KNO3 are added to 100 grams of water, 60 grams KNO3, 100 grams of water, oops, I did it backwards. Careful with your numbers. We chemists can even screw up. 20 Celsius, not 60, 60 grams. 20, 60, we're at like this point right here, okay? How many grams do not dissolve? We've got KNO3. KNO3 says at that temperature, only like 35 are going to dissolve, but we added 60. So you go 60 minus 35 equals 25 grams. Would not dissolve because our point of interest is above the curve of interest. This is how much would not dissolve. So that's the math that I figured out. I just subtracted, okay? I think we got some more examples like that. 30 grams KClO3, 100 grams of water, 25C. So we got 25 degrees Celsius, 30 grams of material. So our point of interest is right about there. And we have KClO3 as our curve of interest. Okay, we see there's a difference. We added 30 grams, but it looks to me like only 10 grams would dissolve. So 30 minus 10 equals 20 grams fall to the bottom. That's the type of math that you'd be doing with this curve. Just subtraction at this point. No multiplication. Okay. Other examples. Finding mass of solute that precipitates after a change. Okay, we're running out of time here, so we might have to do this lesson in class as well. Boom, bada, boom, boom, boom. Saturated solution at 75 is cooled down to 15. How much precipitates? Well, we've got 15 degrees and 75 degrees, and we're talking about NH4Cl. Boom, NH4Cl there, and NH4